Okay, so we saw before that the sine rule could be used when we have a side angle pair and either another side or another angle. If we don't have a side angle pair, we're going to use a rule called the cosine rule. Let's look at an example of that and also the cases where it can be used. So for example, if we had two sides and the included angle, we could use the cosine rule. And here is an example. So I've got two sides, 10 and 5, and I've got the angle in between, which is the 115. So notice I can't use the sine rule here because I don't have an angle and a side that pairs with it. So I'm using the cosine rule. We'll label our triangle. Now, it's really up to us how we label it, but I'm going to label the two sides that I've been given as A and B, which means the angle in between them would have to be C. So if we look at that diagram, you'll see that because I've called this side of 10 A, that means I have to call this angle here A. I've called this side here B, so I have to call that corner there this angle B. That means this angle must be C, and over here this would be side C. Now the cosine rule is a little bit like Pythagoras' theorem. It's c squared equals a squared plus b squared, but we take away twice the product of a and b times the cos of c, the angle that we started with. So c squared equals a squared plus b squared. So that for us is the 10 squared plus the 5 squared. We take away twice their product, twice 10 times 5, and we finish with cos of c, which is cos of 115. So the letter that we finish with is the same as the letter that we start with. It's just that this letter here represents a side, and the letter at the end represents an angle. When we calculate this, we've got to be careful to remember that the right-hand side of what we've done so far needs to be square rooted, because we've got c squared is 167.26. Taking the square root, we get c equals 12.93. The other case where we use the cosine rule is another case where we don't know a side angle pair. And that's where we've still got 3 bits of information, but this time we know all 3 sides. So if we draw a triangle with 3 sides of 5, 7 and 8 centimetres, and label that triangle ABC, and let's say we wanted to find angle A. Well, the cosine rule can be rearranged to make cos A the subject. And we see that we would need to put in the values of little b, up here b, which for us would be this side of 5. We need to add c squared. Now c over here is going to be this side of 7 because it's facing angle C. And we take away a squared, so that's the other side, which is the 8. We then divide by twice the product of b and c, so that's 2 times 5 times 7. Now this gives us the cos of the angle. It doesn't actually give us the angle itself, it gives us the cos of the angle, so I have to do the inverse of cos to find out what angle A is. So if cos A is 0.1429, the actual angle is the inverse cos of 0.1429. We do that using the trig section of our calculator, and we get A as 81.8 degrees. Okay, note that these rules can be written in a number of ways. It really depends on what we use as the labels for our triangle. If we use A, B and C, that's fine. But, you know, depending on where we put A, B and C in our triangle, we can rewrite the rules in a number of ways. It's really just the same rule, but if you look at these rules here, they all have something in common. Whatever side I want to find, I finish with the cos of its angle. So if I wanted to find side B, I finish with the cos of its angle. If I want to find side C, I finish with the cos of its angle. So if I want to find side A, on the right side of the equation you'll see B and C. If I want to find side B, you'll see sides A and C are listed here. And the same if I want to find side C, A and B are listed here and here. So use whichever one of those matches your diagram. Likewise, if I want to find an angle, if I want to find angle A, I can write the formula making cos A the subject, or I can make cos B the subject and use the other letters, or cos C, and so on. Now the reason I've drawn or got a photo here of a crocodile is it's a good way of remembering when you can use the cosine rule when you have an angle, because the thing is both the sine rule and the cosine rule can be used when you have two sides and one angle. If you look at this diagram, you'll notice that we've got an angle here of 30 degrees which forms the jaws of the crocodile, and we've got two sides which form that angle. So this is a case for using the cosine rule. So we can think of this as cosine the crocodile. Somebody shut that dog up! Okay, so in the example here I've got x squared equals 10 squared plus 11 squared minus 2 times 10 times 11 cos 30. So remember that if I want to find a side length, it's the other two sides squared and added together minus twice their product times the cos of the angle 30. If I simplify that, don't forget that I need to take the square root to find x. So we get 5.52. Now, this part here was recorded in a previous recording. It was just a note to show that the sine rule, or rather, sorry, the cosine rule can be written a number of ways. Okay, so depending on how you label your diagram, you can use it to find small side A, small side B, or small side C, or if you're trying to find an angle, we make the cos part of the formula the subject, and likewise we can switch these letters around to suit our needs. Let's just have a look at this example here. This was from the cosine the crocodile example we had before. Just to go over that again, we wanted to find this side x, and we had a pair of jaws here which form the jaws of the crocodile, and we had the angle in between. So that meant we could use the cosine rule. Okay, so x squared was equal to 10 squared plus 11 squared, blah, 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 and then we get to 5.52. I've had enough.